Quick question. Do your end users always, and I mean always, without exception, work on company-owned devices and IT-approved apps? I didn't think so. So how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question: Extended Access Management. 1Password Extended Access Management helps you secure every sign-in for every app on every device because it solves the problems traditional IAM and MDM can't touch. Check it out at onepassword.com/XAM. That's onepassword.com/XAM.
Packet pushers.
Hey, everybody, and welcome to this week's Packet Protector. I'm Jennifer J.J. Manelli here with Drew Conry Murray, and we have a special guest for you guys this week and a topic that I think is on everybody's mind, which is what is happening with our AI overlords. So we actually have Jeff is a distinguished engineer and cybersecurity architect with IBM with a long history of various technologies and architecture, but he's been working recently in everything related to AI, the good, the bad, the ugly, especially as it relates to security and cybersecurity operations. And so Jeff's joining us to kind of talk about, what defines AI. And frankly, you guys listening, this really flipped me on my head and is making me rethink everything about all of the marketing, learning versus programming, what qualifies as AI, what doesn't, which is kind of backwards of how I was visioning it. Drew, I don't know about you.
Yeah, for sure. It was a great way to distinguish it in my mind, yeah.
Yeah. Jeff's got some fantastic ways of describing things like the siloed savants concept. And we're going to talk about specific models of AI that are used in cybersecurity and AI and, operations and detection and response. And then he's going to help us kind of understand and pick apart the different terminologies. So again, the definition of AI, what is machine learning, and then things like reinforcement learning and RAG and supervised and unsupervised and deep learning, neural networks, all of this stuff we dip into a little bit. We have lots of links and resources for you guys as well, because Jeff is a fantastic teacher and educator and has such great videos and resources for us all.
My favorite thing about this episode is that the next time I talk to a vendor who comes at me with some AI, I feel like I've got some questions I can throw back at them that hopefully will make them sit back a little bit and be like, okay, we got to take this seriously.
Yeah, that's the other fantastic part of this. So, all right, let's get to it. So, Jeff, thanks for joining us. We have a long history in technology and security and architecture, but one of the things you've been, I think, thinking and talking about a lot recently is AI, and you've been doing a lot of work in the AI space. And I don't know about everybody else, but probably I'm confused about this still, and I imagine a lot of listeners are. Can we talk about some of the opportunities and benefits of using AI in security functions?
Yeah, sure. And thank you for saying I have a long history. That's a nicer way of saying you're really old. I'll take that. Yeah, 42 years in the IT industry. It's a long history.
Seasoned experience.
There we go. Don't give me any more seasoning. I am plenty seasoned at this point. So first of all, let me say I work for IBM and I've been with them for my entire career. But let me make it clear, my comments on the podcast are my own. So those are my own thoughts, and I'm not representing the company when I say that. And that should, I think, make all the IBM lawyers happy. And then that way I stay out of IBM jail. So that way I can speak a little more freely.
Excellent.
Oh, lawyers.
So AI, fascinating topic. Cybersecurity, also a fascinating topic. Two of those together, this to me is just beyond fascinating. I was interested in AI back when I was an undergrad, when I was riding my dinosaur to class. It was that long ago. And back then, we talked about AI, but nobody even knew the words machine learning. And I've had people debate me on machine learning is the superset and AI is the subset. That's not correct. Or that they're the same thing. Also not correct. So we were doing AI back before machine learning was really a thing. That was back in the 80s using programming language like Lisp and Prolog and things of that sort, recursive type technologies. Then in the 80s came along, late 80s, 90s, I guess, were the expert systems days. Then in the maybe 2010s, that's when machine learning really started to express itself. And that's when, especially in cybersecurity, people started to pay attention. Because machine learning is a very powerful technology. It is a subfield of AI. So AI, the larger field, is just simply trying to match or exceed human intelligence in a computer. That's all it really amounts to. You can come up with a lot of really complicated definitions, but it's just trying to make a computer do what a person could do or better. Now, machine learning is a subfield of that is very heavily involved in pattern matching. And if you feed it lots of data, it will learn certain patterns from that data. There's supervised and unsupervised unsupervised versions of that learning.
Mhm.
The bottom line is it's designed to find patterns. Now, why is that really useful in cybersecurity? Because we like to find anomalies. We care about outliers. So if I can feed it a ton of log data of this is normal steady state operation, now you tell me what doesn't belong here. Where's the needle in this set of haystacks? That's what machine learning is particularly good at. And that's why you hear a lot of cybersecurity vendors talking about, yeah, our stuff does AI. And what they mean in most cases is it does machine learning. So they're not wrong when they say that, but it's left some people feeling like I was expecting it to be more. I thought it was going to be Skynet. And no, that's not.
So, Jeff, let me pause you because what I think I want to do is can we take a little bit of a 101 detour and then come back into the security operations? You just struck a nerve with me and I'm twitchy over here. We are all so sick of every vendor having an AI something. I mean, we've got like AI switches and AI firewalls and AI cloud security and AI toasters. Like you said, I think for most of those products, they're not actually, I'm air quoting AI, they're machine learning or something else. But I think this is where I get confused and understanding like where the lines are. And I've even heard different professionals, I would say probably not people with your level of expertise, but other professionals in the space arguing among themselves about what defines what. So can you just give us like the nickel tour of what is the AI versus the ML that you started down the path of, and then like you supervised, unsupervised learning, deep learning, any other terms that we should understand? And then let's come back because I think that'll give us a better context for understanding, breaking down what we can do in security automation.
Absolutely. And by the way, I'll give a little bit of a detour. I do YouTube videos on the IBM Technology channel. And of those videos, the one that I've done that has been by far the most popular was one called AI versus machine learning. So the fact that you're asking this question means you're one of more than 1 million people that are interested in that topic because it's gotten more than 1 million views, just that one video.
Nice.
So again, AI is trying to emulate human intelligence in a computer, either match or exceed what a human could do. Our existing AI today is sort of like, I'll call it siloed savants. You know, savants are like, if you remember the movie Rain Man, we've got the Dustin Hoffman character who he could do certain things just amazingly well. You know, he could tell you what happened on a particular date, any day of his life, and remember it instantly. But he didn't know how much a car cost, and he didn't know that it was not the same cost as a candy bar. So he had super intelligence in a very narrow space, but was completely unaware in most of others. That's what our AI is like these days. It's very siloed, very narrow. Part of that is because we use very narrow technologies like machine learning, which again is one of these things where pattern matching on steroids. I feed it a ton of data. It starts to build a set of patterns in its corpus, in its knowledge. And then as a cybersecurity person, most likely what I'm going to ask it is, okay, here's a whole bunch of things. You tell me the thing that doesn't belong. Tell me the thing that stands out. People log on, they do activities, they log off. Here's somebody that logged on, created another account, then did some things, erased their log records, and then logged off. Okay, that's an anomaly. That's what I want to see.
Would it understand the context of the anomaly? So I think one of my hopes, I guess, for this technology is it's not just here's a break in the pattern based on things that have already happened, but is there opportunity to tune it or tell it to look for some things that might not be immediately identifiable based on past patterns, but expected future patterns?
Absolutely. This is predictive AI.
Okay.
To do that sort of thing, to say, okay, all of this stuff broke from a pattern, but maybe that is actually just a variation on the existing pattern and it's a norm. Depends on how good your AI is as to whether it can recognize that. As an example, we do predictive AI in vision and in recognition and that part of AI. For instance, if I want to teach a system to know what a chair is, I'm going to send it lots and lots of pictures of chairs. And eventually the machine learning will start to pick out, okay, these are the things that are sort of the qualities that make something a chair. I don't have to describe to it in advance. A chair has 4 legs. Oh, well, but sometimes they have 3, but maybe those are stools and not chairs. And chairs have backs. Well, no, actually, some chairs don't have backs, on and on and on. If we were programming this system, I'd have to come up with every single one of those exceptions and spell them out explicitly. And again, machine learning is a subfield of AI. Machine learning, the system is learning. I'm feeling all these things and saying, all these things are chairs. Now you figure out what makes something a chair based upon all of this. Then I can show you a new picture of a different chair you've never seen before. And if the system is good, it will recognize that that's a chair, even though it's never seen that particular one before, because it has the right set of chair qualities. Now, humans do that all the time. We walk into a room and you see a chair that you've never sat in before, but you know that's a chair and you just go sit into it, sit in it, don't think anything about it. But that's because we have that kind of intelligence to be able to do it. Now, sometimes we get fooled, but most of the time we're pretty good at it. And that's what we're trying to do and apply that in a cybersecurity context. Here's all the normal stuff. Now you figure out what's the abnormal stuff. And if we've done a good job with the predictive stuff, then it can predict that next thing is in fact a normal thing as opposed to an abnormal thing. And that's just with machine learning.
Do we get into the issue of siloed savants when it comes to cybersecurity? Because maybe I've trained this ML on log data, but there's lots of other things you could train on. And security attacks tend to not just be one thing, they tend to be a string of things that somebody had to execute to accomplish. So how do we get away from the silo problem?
Yeah, no doubt that's the case. That's where we are. It's very immature in terms of our use of machine learning, even though lots of vendors have done it. And we actually have seen some really powerful results from it. But I still feel like we're going to look back in 10 years and say, wow, that was Tinker Toys. The good stuff is coming. And I think a lot of the good stuff is going to come out of this newer form of AI, which is a further subfield. So again, think of the Venn diagram. If this is AI, then a subfield is machine learning, a subfield of that is deep learning, and a subfield of that are the foundation models. That's where we get generative AI. That's where you get large language models. That's where you get chat bots. That's where you get deep fakes and all of those things. So they're all subfields of each other. And if you understand Venn diagrams, that means the stuff even in the smallest subfield is still Gen AI is AI. Machine learning is AI. It's not all of AI, but it is certainly a type of AI. And generative AI, I think, is already starting to show us in fields outside of cyber that it's a game changer. And now I'm looking forward to when we make it a game changer in cybersecurity as well.
So you described machine learning as pattern matching on steroids. How would you distinguish deep learning from machine learning?
So deep learning, for instance, is built on machine learning. And that's where we add to it the notion of neural networks, which are how we think the human brain works. I say we think because we're using the brain to try to figure out the brain. And that now ends up being one of these recursive problems.
Hurdles all the way down.
Exactly. By the way, if you don't understand the word recursion, the definition of recursion is C recursion. And I'll just let you process on that for a minute. So if you've got a system that does deep learning, it's got deep, meaning multiple layers of these neural networks, which are associative type of memories. And again, without getting into the gorpy details, that's what deep learning is. Deep learning gets a little bit unpredictable in the way that it works. And I don't know if you've noticed, but human brains are the same way. You might ask a person a question, and based upon their mood, they'll give you different answers. I'm not saying that deep learning has different moods, but I'm saying we can get unpredictable answers, or at least not fully explainable answers sometimes when we start getting into the deep learning phase, which explains why when you go into a chatbot and ask it a question, sometimes it will hallucinate and give you an answer that is just not true. Most of the time, it's really right.
Very human behavior right there.
It is.
I think we just won.
Exactly. And it's interesting when I go to conferences, I do a presentation on AI hallucinating, and I give it some examples where it makes some pretty grandiose claims and I catch it in a lie. And then when it's caught in a lie, guess what it does? It starts trying to spin me and saying, well, it's possible I misspoke. And I apologize if I wasn't clear. No, it was very clear in what it said, and what it said was absolutely wrong, and it was denying that what it told me was wrong. So, yeah, it acts a lot like humans because who did it learn language from? Us. So it will carry forward some of our greatest qualities, and right now it's carrying forward some of our worst qualities as well.
So you also mentioned foundation models. How do they tie in?
Yeah, so the foundation models are the large grouping of things like one example is a large language model, which is what the chatbots are based on. There's other forms of generative AI that make up those language models. We can have visual models and we can have audio models. We can use those models to produce pictures. We can use them to produce videos. We can use them to produce audio recreations of someone's voice. or of a new voice entirely. In fact, a colleague of mine just yesterday took one of my videos off of YouTube and he took a written transcript of it, fed it into one of these generative AI systems, and had it generate a podcast of my video. And it had two voices, a male and a female, both going through a discussion in detail of what was in my podcast. And he said, "Have you heard this yet?" And I'm listening to it. And it's like, no, who are these people? How do they know all about my video? And why didn't they ask? Why didn't they ask me to be on the podcast? And then come to find out, because these people don't exist. These were generative voices that had basically looked at the contents and done the whole thing on their own.
JJ, I think we need to find this machine and smash it, because that sounds like it's putting us out of a job.
I think you should. This is existential.
Whoa, 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 whoa. Or we just hire the machine and we get a little more martini time and whiskey time in the afternoons.
We go on vacation.
There you go. There you go.
That's higher order thinking right there.
I'll just say these AI podcasters were very good, but they're not as good as YouTube.
Aw.
So don't worry.
We love side quests, so we're down a couple rabbit holes here. But a couple days ago, I was making a training thing and I was trying to just make a placeholder graphic for my own draft purposes before I went and drew the whole thing out. So I told the paid ChatGPT with Dolly, and I said, "Hey, can you make a Venn diagram of IT and security functions?" Again, just kind of as a placeholder to shove in there. And I posted it on LinkedIn because it was so hilarious. There's like infosec is spelled wrong everywhere that it appears. It just like made up weird words.
Dolly sucks at spelling.
Why are they so bad?
They just are terrible at spelling. And, sometimes they'll draw people with six fingers, which can happen in real life, but is not typical. It's interesting. I don't know this for sure. This is pure speculation on my part. I almost wonder if in some cases they are intentionally misspelling some things so that you'll know that it was AI generated. I don't know that for a fact, because it seems like to me the easiest thing in the drawing to get right would be the spelling, because you gave them the spelling of the word. So there's got to be something that's happening there that's kind of morphing that, either that or the creativity settings. And some of these, you may not have a setting that's generally available to you, but these generative models, you can choose to change what's called the temperature setting on them, make them more creative or less creative. Now, you can say, well, I want just the facts, ma'am. So I'm going to make it less creative, all the way over on that side. And guess what you get? Boring. It sounds like it was just spit out by a machine, the kind of text that you get from it. So you make it a little more creative, and then you start ending up with more hallucinations. But you get some breakthrough ideas. It's just like with people. If I was writing a poem, I don't want it way down on the cold side where it just sounds like this was a machine generated poem where, okay, it rhymes, but doesn't really move me. But if I move it way over on the more creative side, okay, it moves me, but wow, that's really something from out of left field. There's some context where you want the more grounded truth and others where you don't. And my guess is these visual models right now are not letting you tune that. And I'm not sure exactly why.
If we apply that idea to cybersecurity, can you envision cases where you might want an AI system, an ML system, to get a little creative and risk some hallucinations? Let's pause for a message from today's sponsor, 1Password. Imagine your company's security is like the quad of a college campus. There are nice brick paths between the buildings. Those are the company-owned devices, IT-approved apps, and managed employee identities. And then there are the paths people actually use, the shortcuts worn through the grass to the actual straightest line from point A to B. Those are the unmanaged devices, shadow IT apps, and non-employee identities like contractors. And most security tools only work on those happy brick paths, but lots of security problems take place on the shortcuts. 1Password Extended Access Management is the first security solution that brings all these unmanaged devices, apps, and identities under your control. It ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management solves the problems traditional IAM and MDM can't. It's security for the way we work today, and it's now generally available to companies with Okta and Microsoft Entra, and in beta for Google Workspace customers. Check it out at onepassword.com/XAM. That's onepassword.com/XAM. And now back to the podcast.
I can. In fact, sometimes what will happen is we are too far inside our box. The bad guys are successful because they don't think inside the same box that we're generally confined into. We have a job, a 9 to 5 or a 9 to 9 or whatever it ends up being for us, but we've got certain constraints and we've got certain ways of thinking about things. We work within an organization, within the context of that organization. The attacker is not weighed down by any of those constraints. So they come in out of left field with a brand new idea of how to break this system that none of us ever dreamed of. And that's why they're successful with the big attacks. So yeah, if I had an AI that thinks outside the box, that's very creative, it's going to come up with some ideas to suggest to me, this is down the road, what kinds of things would be vulnerabilities in my environment that I hadn't considered.
Mhm.
A bad guy might try this, and I'd want it to be real creative. Now, if I turn that setting way up, it may be real creative and it comes up with one good idea out of every 10 or 20, but there's going to be a lot of other stuff that you're going to look at and say, that's just absolute nonsense. But it'll still be worth it for the one idea out of 10, because that's one we would have never come up with if we were just thinking conventionally.
So maybe this is context dependent. If I'm in the heat of an incident investigation, I want out on the cold setting, just the facts. And if I'm maybe running a tabletop exercise, let's get a little crazy.
Maybe you're in the midst of one of these things, and here's the beauty of AI. We could run multiple models simultaneously. So we could have one that's set on the cold side and it's just going to tell me, here's the raw facts. And then the other one is kind of suggesting some things out of left field. If I'm not able to solve the problem pretty quickly with the more conventional thinking, well, maybe I might want to infuse some of these other ideas. It's like having this creative colleague who blurts out a lot of nonsense, but every once in a while says something that's genius. And you're like, okay, I'm going to keep you on the team because every once in a while you say something that's genius.
I suddenly feel like there's a Monte Carlo model of temperatures and AI output suddenly where you just get this giant, graph of random stuff.
Exactly right. Yeah.
Wow. So kind of coming back to our detour and then coming back to the first question we had. So the detour question that you answered, which was kind of like, what is AI and what do these terms mean, is really interesting to me because what you're saying is completely opposite of what I thought I understood, which was, okay, these vendors are not really doing AI. They're just slapping an AI sticker on everything. But what you've just said is it's all varying degrees and types and flavors of AI because AI is such a large umbrella.
I think that's right. I think it's also fair, the criticism that you put out, that a lot of people have slapped AI stickers or sprinkled the AI pixie dust on things that really wasn't deserving of it. And a lot of people think anything you do with a computer, okay, that's AI. I had a debate with someone one time who said, okay, well, we have a system that can generate graphics, therefore that's generative AI. And I said, no, it's not. Generative AI has a specific meaning. Just because you have a system that can generate content doesn't mean it's generative AI. So yeah, the terms have been abused.
That's the other little bow I wanted to tie on that. Are there legal definitions? Because one of the things we've already seen was, Drew, remember we covered a news story where someone in the investment and financial space was advertising use of AI in their models for some service that they use for their customer base. It was determined that they were not actually using AI. I'm air quoting AI because I don't know what all that entailed. They were fined for false marketing information. So where is that line for vendors that are using technologies?
Well, apparently there isn't one. I've seen them like drunken drivers all over both sides of the road when it comes to this. And by the way, this isn't the first time we've seen this. We saw this same phenomenon when it came to zero trust a few years back, when every vendor co-opted the term zero trust and abused it beyond recognition. And look, I'm a cybersecurity architect. I actually believe in zero trust. I think there were some valuable concepts and still are some architectural concepts that are useful and instructive. But the problem is so many vendors co-opted the term and abused it so that now you can't have a discussion about zero trust because people just tune out. They're like, okay, zero trust, that's marketing code word for sell everything I've got on the truck.
Are there questions or indicators or things to look for to go, okay, vendor, you are actually are doing something, novel or AI versus not?
I think so. Well, first of all, I'll go back to zero trust as the example and then bring it forward. In zero trust, there's this concept of assumption of breach. And that is an absolute game changer. We normally assume we build a system, the bad guys are on the outside and the good guys are on the inside. If I assume that the bad guys are already on the inside and now I'm going to construct my security, it's a game changer. Totally different. How would you design security for your home if you assume the bad guy's already inside? Well, you're not going to be so preoccupied on just the perimeter defenses because he's already gotten past those. So that's an example where I say zero trust is still a valuable concept for us. Now, moving to AI. I don't know that there are any legal definitions, but I'm not a lawyer, so I'll give that caveat out there. I do think for something to be AI, I think it needs to be a system that learns. Now, just because it learns doesn't mean it uses machine learning. We had systems that learned before we came up with the term machine learning. That is a particular technique for making a system learn. But a system that is programmed is not the same thing as one that learns. That's one major difference. Now, whether it learns in your environment or it learned when they were building it, that could be a different situation. But I would expect an AI system that is conventional today. It's going to use probably machine learning. There are almost no real AI systems, I think, out there today that don't leverage machine learning. Now, they may also leverage deep learning and generative AI, but remember, those are subfields. So machine learning is a part of those things as well. And just to say, my system learns and it's a machine doesn't make it machine learning. There are more academic definitions of what that means.
What's the nuance between a system that's programmed and a system that has learned in a pre-built environment?
Going back to my undergrad days, I was a computer science major. You're basically taught to be a programmer. And a programmer is somebody who comes up with an algorithm, turns that algorithm into instructions, puts that in code, and then puts that into a system. And the system will execute faithfully what it is exactly what you told it to do every single time. And if you want to make it do something different, well, you got to change the code because it's going to do exactly what you told it to do and not more. Now, an AI system, in my view, is one that certainly has some programming, but the programming is very different in this. It's more the same way a person learns. People are not programmed. I mean, we go to class, we go to school, we learn things, but we're not programmed. We don't fully follow all the instructions that we're given, for better or worse. If it were as easy as programming people, we could just plug a USB drive into the side of the head and download all the info, and then we'd be done. But we conceptualize things, we internalize these things, we apply them in different ways. And those are kind of the hallmarks of what we consider intelligence and what I would consider artificial intelligence if it's not done in a human, if it's done in a machine. So I would expect that an AI system would be able to look at my data and over time learn and get smarter. If I'm looking for user behavior analytics, if I'm looking for user anomaly behavior, then I would expect the system to get better over time the more data I feed it. A system that has to be programmed isn't going to get smarter until I change the programming. And a system that's using machine learning should get better the more data we feed it. And we can make some course corrections, but I'm not cracking open the code and writing new lines of code. I'm just saying, no, giving it feedback. No, that's a wrong answer. Yes, this is a right answer. No, that one's wrong.
So we've had systems that have said they do anomaly detection. We've had that for years before AI and ML emerged as a marketing term. How would you differentiate sort of a classical anomaly detection system versus something that is using machine learning or AI?
Yeah, the classic ones are built on rules, which is just another form of programming.
Okay.
If I can dream up the scenario, if someone does A, then B, then C, then that's okay. But if they do A, B, and then Z, that's not okay. I have to build those rules, configure them into the system, like a security information event management system. It's got rules typically, the conventional ones. And I have to build every one of those rules. And whenever one of those rules fires, those conditions are met, then it will let me know. That's another form of programming. It's just you're doing it in configuration rather than actually writing code to do it. Versus the modern SIM systems combined with not only those things, but they also combine machine learning capabilities so that they really do get smarter over time. The more data we feed it, a bad system, more data is just more data. A good system, more data is more insights. And that's when you know you've got something that's really doing it.
And by smarter, do we mean sort of like it can make novel associations outside the bounds of strict programming?
And fewer false positives, because now it's seen enough of those kinds of things. And we've trained it because when it fired that and said, hey, I think this is a problem, we investigated and said, no, it's not a problem. It shouldn't keep firing that every single time. If it is, it's not learning. If it is learning and it learns from feedback, then it should be getting smarter and not give as many false positives.
Is there a difference between the technology that drives something that is, to me, there's still just a fine line here, not knowing all the under the hood things, but is there a difference in the underlying technology of something that helps teach itself versus relies on how we respond to the data to train it? You just use the example of if we keep dismissing the alert, which so now it's relying on us. It's kind of like a toddler or kid still having an adult go, worry about this, don't worry about this. Are there models that are a little more adult-like in their thinking where they understand how to interpret the data without other input from us?
Yeah, so the first is reinforcement learning, and that is part of what we do in AI to train a system is through human reinforcement. The output comes out, and you see these a lot of times in chatbots. It said, did I answer your question? Thumbs up or thumbs down. So that's reinforcement. Now we have to be careful with that. If we turn that loose to the general public, then a bad actor could intentionally try to confuse the system and say it's thumbs down when it really was thumbs up and vice versa. And theoretically, if you built the system right, a few of those won't matter. It will only see once it's seen a preponderance of those kinds of feedbacks that then it starts changing the way it thinks. So reinforcement is one way. Another way is to tune a model. That is to give it different kinds of information. It's got a base model that it was trained on, but then we tune it. And that is something that happens not from the end user perspective. That's something that the model, either model developers or the users of those models can do. And then the other thing is going further back in the life cycle is actually use different things to train the model. Another technology that I think is important, the corpus is the knowledge base that we train the thing from. So I could choose to include more things or fewer things. I could take certain things out that I think are causing it to get confused and add other things in its place. Or once the system's already operating, one of the technologies, one of the architectures we see is called RAG, Retrieval Augmented Generation. With a traditional chatbot, let's use that as an example, the prompt is what I type into it. I ask it a question and it gives me an answer back. And if I say, tell me something or other, then it goes into its model, into its training corpus, and it's going to try to come up with an answer based upon what it already knows. Now, one thing I may want to do is say, I don't really want you to rely directly on that. I want you to summarize this document. So summarize this document. And by the way, here's the document. Here is a different data source. And I want you to confine your summarization or your analysis to this particular piece of information. That cuts down, if we do it right, cuts down on hallucinations because we're telling it this is a trustworthy source. Some of those other things that you might have been trained on might not have been trustworthy or might not have been relevant. So we can, with RAG, give it the prompt and then have it pull in a data source that we think is trusted and relevant for this, and then have it do its generative twisting and turning and machinations, and we get a result that is more grounded in truth and reality that we're looking for.
So RAG allows an AI system to incorporate new information that wasn't in the original model it was trained on?
Exactly right. That's one of the things. If you go to one of the chatbots today and say, what's the weather like now? It doesn't know because it only knows what was in a particular snapshot in time when its data model was created. And that's what it was trained on. If we want this to have real-time information, well, we're going to have to get that from another source. And RAG is a way to bring in other sources. And they could be static sources, they could be dynamic sources. But that's another way of infusing information into the process.
Let's maybe back up to how this kind of more fits into the security operations.
If you want an example of how this could be used, I'll give you one. In cybersecurity, one of the things that we have to do, we've got to go look at and analyze a case. Somebody is trying to break in. Maybe they did break in and we haven't figured out how. So somebody now has the responsibility to go off and investigate that. And maybe it's a long investigation. Maybe it takes a couple of weeks. And the chief information security officer is getting pressure from the board to explain what's happening. So the CISO comes to the cybersecurity analyst and says, okay, I've got a board meeting, tomorrow, and I need an update on where we stand with this. So now the analyst would have to take away time from doing investigation to go look at all the case notes that we've gathered over the last 2 weeks, all the indicators of compromise. What does all this mean? Where do we stand with it? And write that report, which is not a good use of their time. because they're not off solving the problem. Here's something generative AI can do. It can generate summaries, and it can do it really quickly. So what if we used, for instance, as a RAG source, here are all the case notes on this that we've collected so far. I want you to generate an executive summary of 500 words. Bang, there it is. No more 2 hours of writing the report. Or if I want to do a handoff to the next shift, because I'm not going to work 24/7, and the next shift comes on, they just want the bullet point technical details. Where does the case stand? We could ask it to do a different type of summary where it's giving a technical summary. Or we could ask for a narrative summary that tells it more in terms of a timeline. Okay, first we saw this, then we saw this, then we saw this. 3 different kinds of summaries, and generative AI could generate those for us in almost no time. And it would take a person a decent amount of time to write all that stuff up. That's a force multiplier. And I don't think anybody would complain, oh, yeah, the system took away my job. Now I don't get to write those reports all the time for the boss. Most people are not loving that.
I do feel like we have to make a quick side comment here, which is if we're talking about putting in something like a breach incident data into a model, I'm going to assume the guidance here is not into public models.
Oh, goodness, no. And in fact, here's the other thing that is often misunderstood. The model itself generally doesn't change much. In fact, most organizations will never build a model. It is too expensive. It is millions, sometimes tens of millions of dollars to build a model, and many months of effort and a lot of compute time. So what most people are going to do is leverage an existing model. And there are more than 300,000 existing AI models out there. You can go to a place called Hugging Face, which is essentially the GitHub for AI models, and they're all sitting out there floating around. And by the way, not all of them are good. And some of them could have malware installed in them. So be careful where you get your stuff. But the point being is we're probably not going to change the model. What we might do is tune the model, but we're not going to tune it in real time either, because that's an expensive process also. What we're going to do is use RAG to feed stuff in, and that's where I'm going to get this stuff. It's not going to change the base model. Now, to your point, though, you should assume if you are using a publicly available chatbot, that whatever you say to it, you have said to the internet. Now, maybe they've done some controls, but a lot of cases haven't. There was one company in particular that their programmers were using a well-known chatbot. I won't call out the names to protect the guilty in this case. They were using this and they were feeding their proprietary source code into this chatbot in order to have it help them with debugging. Well, once they fit it in there, it's not proprietary anymore. It's now an open secret because that company has the right to use the information as they want. So I would say if it's sensitive data, you want to make sure you're dealing with a company that builds this where your data is your data, not your data is our business model. And by the way, if you're not paying for it, you are not the customer. You are the product. So if it's free, that's the cost.
TLDR, don't go pasting any config files, outputs from breaches into, Chat GPT.
Do not, absolutely not. But there are vendors who can give you a private instance.
Yeah.
And then your stuff goes in there and it doesn't go and inform all the other models in the world.
2 questions. The first, are models separate from the data corpus they're trained on, or are they sort of too inextricably bound to be considered separate?
Yeah, so we start with the corpus. These are all the different data sources. This is the knowledge base. And then the model is built from that. And then the model is what we do inferencing against. So imagine the original data sources of the corpus. The model is what we generate from that. And then the inferences are the output that we get as a result of all of that.
So you mentioned there's a lot of models out there, and we talked earlier about foundational models that underpin things like LLMs and visual generators. Are there foundational models being developed or that are emerging specifically for cybersecurity?
Yes, there are. Some of them will be not only cybersecurity, some of them will be general IT models, but they've been infused with a lot of extra cyber knowledge and sources like that.
Okay, so it's been trained to look at sort of typical IT data sources like log files, IP addresses, that kind of thing.
Right. And understand the nomenclature of IT, the concepts of IT. If we were to build a medical model, we'd want it to know about anatomy and, things like that. So the way the systems of the body work. Well, there are models that also understand how the systems of IT work. And then there are more general purpose models that include both of those, along with a lot of other things. Those are the ones that are the really massive models that amaze us. When we go to it and ask it questions, it seems to know the answer to everything. And most of the time it's right. Not always. And the fact that it's not always right is, in fact, the problem, because we can be lulled into a sense of complacency and believe everything that comes out of it. Because 9 times out of 10, what it says is really spot on, but it's that other 10th that's troubling. This is why one thing I do on the side, I'm an adjunct professor at NC State University. And the big thing that I'm trying to infuse in my students, I mean, I want to make them aware of cybersecurity architecture and these kind of things. The big thing is critical thinking. I do a whole class, runs across 2 semesters, called Secure Thinking, Issues in Cybersecurity and Privacy. And that's what the class is about. It's about thinking in a secure way, critically about, here's a new technology. This is really great. What could go wrong? What could possibly go wrong? And the answer is always something. And the bad guys will answer that for us if we don't answer it first. So I think in this era of AI, critical thinking has become more important than it has ever been. There's certain skills that we don't teach kids anymore, like writing in cursive, and we can bemoan, all of us oldsters that they don't know how to read cursive or write cursive. Yeah, but we also, a few generations back, they were bemoaning the fact that there weren't enough blacksmiths anymore, that those were all being put out of business. Skills change over time. And I think the skills going forward that are going to be most important are critical thinking skills. And we're not particularly good at that. Just look at how we fall for all kinds of fake news, and now add in deep fake news. That's going to be a real problem for us.
So I have a question related to some of the security operations. If we just kind of loosely, for demonstration purposes, think about security functions using the NIST core functions of, identify, protect, detect, respond, recover, right? The things that happen before an incident and the things you do after. One of the things I saw in that breach report, so IBM has a cost of breach report that's done by a third party that's pretty cool. And, one of the stats was like the average cost savings for a company that used AI and automation in these functions was, like $2.2 million lower than the cost for others. So my question for you is, given the technology situation we're in now, like wherever we are now with it, where are the biggest opportunities for AI and automation here, and where should we not be relying on it?
Yeah, sure. Well, first of all, a plug for the video I did that goes along with that report. So if you go on the IBM Technology channel, I've got a video on the 2023 report as well as the 2024 report. If you want to read the whole report, please do. If you want the 15-minute summary, then that's where you get it. And that's one of the things that I highlight in that is that, so first of all, the average cost of a data breach worldwide is about $5 million. That's average. And then you talked about saving roughly $2 million for the organizations that were making extensive use of automation and AI. That's a big savings. That's a big chunk.
Yeah, I mean, that's half.
Almost half, right. Will this stuff pay for itself? Yeah, we've got the numbers that say that. And that's not us making them up. When Ponemon Institute is the group that goes out and does that, IBM basically contracts with them to go out and conduct these interviews. And they talk to people from like 600 different organizations that have had data breaches. So it's a large data set that they can base these conclusions on. Now, to be fair, the AI that they're using has largely been machine learning up to this point, because generative AI is just now really starting to make its way into the cybersecurity space. So there's a lot of negative stuff that can happen with AI. And I'm a cybersecurity person, which means I'm an expert at finding the dark cloud to every silver lining. And I can find all the faults of how AI is going to mess us up. But one of the things that's promising is we haven't even begun to start leveraging generative AI to improve cybersecurity outcomes. So I'm hopeful that's going to make an even bigger difference in the future when we move from using just machine learning in that, but also starting to use generative AI, having it suggest, here's another Gen AI use case that I think is nice. Imagine you're an analyst and you're trying to look at a log record. And in this log record, there's some complicated syntax for a command that you don't understand. Now you got to go off and search that on the web and look up the manual and figure out, okay, with this exact set of parameters, what was that going to do? Well, large language models.
That's me and regex every time.
There you go. So how about a large language model? Because think about, those things are languages. SQL is a language. So if we've got a SQL query and I don't understand what the results of that were going to be, why don't I feed that into the LLM and have it tell me a command line explainer that says, oh yeah, when they did this, this is what the results of that were going to be. That'd be a big time savings as well. And again, that's augmenting the capability of the analyst and making it so that they can do more in a shorter period of time.
Maybe a question to wrap up on, because I know we have to let you go soon, Jeff. But this talk about models makes me wonder, like thinking about like if I buy a security appliance, I want to get a sense of, what OS was it built on? If it's Linux, I'll put it in one sort of risk bucket. If it's Windows, I'll put in another risk bucket. If the vendor built their own OS, I'll put that in a third risk bucket. Should I be thinking about the models that my vendors are using, my security vendors using in the same way? Does it matter that much?
Yeah, I think you should. The problem is a lot of times that's not something that's exposed to you. It's like if you were buying something and you couldn't see what the ingredients, imagine food that you were buying. You'd like to see the FDA label or whatever, the nutritional value of what's in this thing. This is now basically a governance question about the AI. And a lot of the commercial off the shelf products are probably not going to expose all of that to you. I do think this is an important aspect of trustworthy AI. In fact, the transparency of the system so that I can know what models went into this, where were they sourced from, what did you use to tune them with, what version of the model are you using? I think these are all reasonable things that people should want to know at some point, although probably right now they wouldn't know what to do with it, even if they had the information. So who knows? Maybe that will be something that becomes, an expectation when people write up RFPs in the future. They're going to want to see which model you were using, or they take a more pragmatic view and say, okay, look, we're just going to hold you liable if your product doesn't work. So,
And we just had an episode not too long ago that Drew did on S bombs, and I kind of feel like maybe this isn't something that's going to get rolled up into that program of understanding what's driving the software and the behavior and the decision. Seems like a critical piece.
I think so. And as these systems get more and more complex, and I remember what I told you about deep learning, it gets more and more unexplainable, which is going to, I think, mean we're going to need more and more grasp. The black box thing is where we could start getting into trouble. If the AI is just saying, trust me, okay, well, okay, trust but verify. So I need a little more transparency in the system for me to trust it.
Well, Jeff, we're at the end of our time, but thank you so much for helping certainly me understand the potential and the challenges of AI and ML.
Absolutely. Thank you all for the opportunity. These are fascinating topics to me, and I hope it was useful in the discussion.
And Jeff, I plan to see you around Raleigh somewhere, and we'll definitely plan to have you back. There's a lot of different topics. There's so much more to dive into in this particular topic. So I'm sure we will be listening and seeing you again soon.
Absolutely. I look forward to that.
Well, thanks, Jeff, for joining us. And thank you for joining us for another episode of Packet Protector. If you have a topic you want us to cover, you can find us on LinkedIn or at packetpushers.net/community, where you can join our free Slack channel with other IT and security pros. Got a comment, correction, or question, you can reach out at packetpushers.net/FU. The FU is for follow-up, and we do appreciate when listeners reach out. As always, make sure you eat your security vegetables.